Now in MyPad World, our sample app for the iPad, we just removed Falling Image View from the Superview and released Falling Image View because we own any object we create with Alloc, and we must release it when we're done. But that's not all we're responsible for. We have to free up memory. We have to always assume that low memory conditions prevail, and that the view controller will need to release its view and any objects associated with the view to free up memory as soon as it's finished with them. Now here we are back in MyPad World, and you'll recall that the main loop, which is down here at main.m, does three things. The first, most important thing is it sets up this auto release pool. And this is what we use for a reference counted memory management system. It stores objects that are sent a release message when the pool itself is drained. The other thing it does is it calls the UI application main function to create the application object, its delegate, and the event loop. The other thing that it does in relation to memory is that here it does a pool release right here. And that releases the auto release pool, freeing up memory from your app. And so the auto release pool is really part of another design pattern. It's called the managed memory model. In the managed memory model, one of the main responsibilities of all good little applications is to deal with low memory. The first line of defense is to understand how you can help avoid getting into that state in the first place where you're running out of memory. In iOS, each program uses the virtual memory mechanism found in all modern operating systems. But virtual memory is limited to the amount of physical memory available. This is because iOS doesn't store changeable memory, such as object data, on the disk to free space and then read it in later when it's needed. Instead, iOS tries to give the running app the memory it needs, all of it, freeing memory pages that contain read-only content, such as code, where all it has to do is load the originals back into memory when they're needed. But of course, this may be only a temporary fix if those resources are needed again a short time later. And if memory continues to be limited, the system may also send notifications to the running app asking it to free additional memory. And this is one of the critical events that all apps must respond to. You must observe low memory warnings. Now back in MyPad App World, if we look at the controller implementation file, MyPad World View Controller.m, we see here in the memory management section a did receive memory warning method. When the system dispatches a low memory notification to your app, it's something you must pay attention to. Otherwise, it's a reliable recipe for disaster. And what you do is you implement the application did receive memory warning method of your app delegate. Your app delegate could then release any data structure or objects it owns, or notify the objects to release memory they own. But another thing you can do is override the did receive memory warning method in your view controller, which is what is happening in this template code. The view application template put in this method here, did receive memory warning, so that we can release the view if it doesn't have a super view, and release any cached data, images, or other objects that aren't in use. This way, the view controller can release views or even other view controllers that are off screen, and we can customize this method as we need to. Now, how does this memory management model actually work? First of all, when you create an object, a window or a button, for example, the memory is allocated to hold that object's data. The more objects you create, the more memory you use, and the less is available for additional objects you might need. So obviously it's important to make available, that is, deallocate the memory that an object was using when the object is no longer needed. This is very basic memory management. Now iOS uses reference counting to figure out when to release the memory allocated to an object. It's your responsibility as a programmer to keep the memory management system informed when an object is no longer needed. Reference counting is a very simple concept. When you create the object, it's given a reference count of 1. As other objects use this object, they use methods to increase the reference count and to decrease it when they're done with it. When the reference count reaches 0, the object is no longer needed and the memory is deallocated. Now here are the basic rules of memory management. Any object you create using alloc or new, and any method that contains copy, and any object you send a retain message to, they're all yours. You own them. That means you're responsible for telling the memory management system when you no longer need the object and that its memory can now be used elsewhere. Within a given block of code, the number of times you use new, copy, alloc, and retain should equal the number of times you use release and auto-release. You should think of memory management as consisting of these pairs of messages. If you balance every time you create something with a release, your object will eventually be freed when you're done with it. And one other thing to remember is that when you assign an instance variable using an accessor with a property attribute of retain, retain is automatically invoked. That is, you now own the object. You got to implement a dealloc method to release the instance variables you own. But you don't have to worry about objects created any other way, such as through convenience constructors or accessor methods. They're not your problem. But a direct correlation does exist between the amount of free memory available and your app's performance. If the memory available to your app dwindles far enough, the system will be forced to terminate your app. To avoid such a state, keep a few words of wisdom in mind. One is minimize the amount of memory you use. Make that a high priority of your implementation design. And two, be sure to use memory management functions. Okay, back in MyPad World, in the MyPad World View Controller, we have several methods to look at for memory management. We have dealloc up here and did receive memory warning. We also have, down in the view unload section, the view did unload method. Now, view did unload is sort of the counterpart to view did load. You use it to relinquish ownership in the view and its objects. So if you look at view did unload, it unloads the super view, and then we get to release any retained subviews. It even gives an example of how to do that with self myoutlet equals nil. So what we've done is we've said self image view equals nil and self falling words is nil. What we're doing is using the preferred method of relinquishing ownership, using the corresponding accessor method to set the value of the object to nil. Now, because the view controller also stores references to views and other objects, it's also responsible for relinquishing ownership of those objects safely in the dealloc method. We're back up here to the dealloc method, and here it is. And here we have also put in the self-image view to be nil and self-falling words to be nil, right before deallocating the super view itself. The object's dealloc method is invoked indirectly through the release instance method of NSObject. Subclasses must implement their own versions of dealloc to allow the release of any additional memory consumed by the object, such as dynamically allocated storage for data or object instance variables owned by the deallocated object. And after performing the class-specific deallocation, the subclass method should incorporate superclass versions of dealloc through a message to super. And if you're building your app for compatibility with the older version of iOS, say 2.0, your dealloc method should release each object, but should also set the reference of that object to nil before calling super. And that's what we've done here.